Hi, this is Alice Conjamie Pollock, and I'd like to look at the personal finance formulas and do a few examples, show you where students tend to make their mistakes when working with these formulas. First of all, let me explain what each formula is used for, because one of the big questions is, when do we use what formula? These two formulas are used when you're computing simple interest. Remember that simple interest is when you do not earn interest on your interest. It's generally used for very short-term investments in short-term loans, usually 30, 60, 90 days in general. Interest equals principal times rate times time. If you're in my class, we will be using this formula sheet. It will be given to you in problem 1 of your exam. You will not have to memorize what is printed here, but anything not printed here you will need to know. So you need to know what each of these variables stand for. The amount in the account is equal to the principal times 1 plus the rate times time. Now know that the rate is your annual percentage rate. Your time is always time in years for these formulas, and your principal is the amount of money you're investing or borrowing. Now, you will use the compound interest formulas. That would be these two. The compound interest formulas, when you're told a certain amount of money is invested at 5% compounded monthly. When you hear the word compounded, you're going to use your compound interest formulas. And for investments, compound interest is very good. That means that you earn interest on your interest. So you will hear compounded and know that you're going to use these formulas. This says amount equals principal times 1 plus rate over number of times compounded per year to the number of times compounded per year times the number of years. Remember, T is time in years, N is number of times compounded per year. Now, these two formulas are actually the same. One of them is solved for A, the other is solved for P. So if you know your algebra, if you want P by itself here, you would divide by this term, and you get A divided by this. This one, if I say you invest $10,000 at 5% interest compounded monthly for 6 years, you would use this formula. If I say I need $10,000 in 8 years. Now I'm giving you the amount that I need. So I would use this formula, and I would put $10,000, which is the amount I need, and find out how much principal I would need to invest today at 8% interest compounded quarterly for 8 years. And so once it gives me that information, if I know how much principal I'm investing, I will use this top formula and find the amount that's in the account at the end of the time period. If, however, I know how much I want in the future, and I don't know how much I need to invest right now, what principal needs to be invested right now, then I would use this interest formula, compound interest formula. There's one other compound interest formula not on your sheet that you will have to memorize, but it's very simple. It is the continuous compound interest formula, which is principal times little e to the rate times time. Little e, I define it in my face-to-face class. You're just going to use it. You're looking for that key on your calculator, little e. It's called the Banker's constant, or Euler's constant. He's the one who came up with it, or discovered it. Now, that says your principal times, and you're going to find the little e key. It's normally around the log key on your calculator, and it's automatically going to throw you into an exponent, and you're going to say the rate times the time in your exponent. Now, let me stop a minute. That one you'll need to memorize, but it's A equals PERT. I always remember that because PERT shampoo, it's the shampoo and conditioner in one. It's in the green bottle. It smells fantastic. It was back before Pantene. It was the first conditioner and shampoo in one. So remember it that way. But there's a key thing in these formulas that people will miss the problem because of this. And I want to show you why, and then I'm going to go back and write in these formulas, and you'll need to remember to do that on your own paper when you're taking an exam or working these problems in your homework. I want you to see this. If I want you to do 3 plus 1 to the 2 plus 1, if you enter this in on your calculator just as it sits, if you put parentheses, 3 plus 1, parentheses, to the, and put 2 plus 1, your calculator is going to see this. Oops. It will see 3 plus 1, and then you're going to say to the 2 plus 1. Your calculator will go 3 plus 1 to the second power, which is going to be 4 squared, 16, and add 1. Your calculator will give you 17, and that's the wrong answer. If I want that taken to the 2 plus 1, I have to make sure I tell my calculator to take it to that entire power, which means I need to put parentheses around the 2 plus 1. Now I will have 3 plus 1 is 4. To the 2 plus 1 is 3. My calculator will give me 64, which is the correct answer. Now, why am I saying this? Because on these two formulas, if you do not put this n times t in parentheses, it will not know to take it to the power of n times t. It's just going to take it times to the power of n, and it'll multiply your whole answer by t. So you don't want that. So you will need to remember to put those parentheses. Now, let's also talk about this formula real quick. This is your effective annual yield formula. And what it's going to give you is, it's kind of a common denominator of interest rates. What it does is it allows you to compare, like if I say which is better, 5% compounded monthly or 5.25% compounded quarterly, you would say, well, I'm going to put my 0.05 for my 5% compounded monthly, 0.05 divided by 12 to the 12th here, and you'll fill in with this formula, and it will give you a decimal, and you'll change that to a percent. That is your effective annual yield, which is your simple interest rate, which would give you that same compound interest. That way you can compare your interest rates. So I would put each of those in this formula and find which one was higher, and that's the one I would want to use for my investment. All right, and you'll see problems like that in your homework. That one's not too bad. Now let's look at, so that one you will be using whenever they say which is a better interest rate, or what simple interest rate would give you 8% compounded monthly. You're going to use this effective annual yield formula when it asks you that. Now, annuities. Well, first of all, what is an annuity? An annuity is when you invest by making equal payments at the same time. So in other words, whenever you invest in your 401k and you put in $100 a month, then you would use this formula and say, how much am I going to have in the account? That's A, amount. If I invest $100 a month, that would be my principal. And then I'll plug into this formula. You'll have to know what percent that account is earning. How often, if you're putting in $100 a month, then you're doing this monthly, so N would be 10. Remember, N is the number of times compounded per year. T is the time in years. And on this one as well, you will need to put that exponent in parentheses. Do not forget. We're going to work an example, so you'll see. Again, the annuity formula, when do I use that? When you are investing. You are putting the same amount in the account over and over. With my compound interest formula, you're not making a payment into an account. You're going to put $3,000 in an account and let it ride. It's just going to sit in that account and earn interest until you take it out in 5 years. That means I'm using the compound interest formula. The annuity is when I'm making a payment, an equal payment. Every year I'm going to put $1,000 in an account for 10 years. That's an annuity. I'm going to put $10,000 in an account and let it sit for 5 years. That's just compound interest. So I'm going to be using this. Now, again, just like my compound interest formula, if you're making a $100 payment every month and you want to know how much you're going to have in the account at the end of 10 years, 20 years, then you're going to use this formula. However, what if you say, I know that I'm going to need $200,000 in my 401k when I retire. I know that's going to be 30 years from now. I know that the account is getting a certain percent interest and it's going to be compounded per month. I'm going to put a payment in every month, and you want to find out, to have the $200,000 in your account, what payments will you have to make for that period of time? So if I need to know what my payment should be, I'm going to use this formula. If I know how much I'm putting in the account and I want to know how much is going to be in the account at the end of my 20 years, then I will use the formula that gives me the amount. Okay, now that's an annuity. Then we also have our amortization formula. Now, to amortize a loan, amortize is actually a verb. It means you're actually doing something. The root word in amortization or amortize is mort. Mort means death in Latin, and to amortize a debt is to kill the debt, so you're paying it off. You're going to use your amortization formula when you are paying off a debt. So if you're talking about paying off your credit cards, you need to use your amortization formula. If you owe $2,000 to the credit card and you're going to have to make payments to them over 2 years to pay it off, you would use this formula. If you're buying a car, the amount of money that you are borrowing is your principal. This is your payment. So if you're buying a $20,000 car, you're going to put $20,000 for principal. You're going to look at the rate of interest you're getting. Usually it's compounded per monthly because we usually make monthly car payments, although sometimes it's weekly. It depends. If you have really bad credit and you're going to a place and they don't trust you, they're going to make you pay every week. Hopefully you're not one of those people and you don't have to worry about that. Now, again, on these formulas, make sure when you take to a power, you are putting that power in parentheses. One other thing you need to make sure of on this is it is to a negative power. We're not deriving these formulas. In my finite math class, we derive the formulas, but in my math for liberal arts or my quantitative mathematics class, we don't derive the formulas, so I'm not deriving them here. But that is a negative sign, and you cannot hit a minus. You have to use the negative sign in this formula. If you hit the minus key, it's going to give you an error. The other thing that a lot of students forget is they don't put the double set of parentheses in the annuity formula. You have to hit parenthesis, parenthesis. Okay, so make sure you do that. All right, so that's how we use these formulas, those are the formulas and when we use them. Now, I just want to really quickly, because I do a whole spiel on this in my class and I think it's so important, I want to tell you, beware of payday and title loans. We actually have laws that say they have to give you the annual percentage rate, but they usually try not to do that. And I know I Googled a bunch of them, and man, it was very difficult to find, although it was on all their sites. When you go to a payday loan or a title loan company, you're usually at the end of your rope. You've got to have money quickly, and they take full advantage of that. If you have a friend to borrow from, I would do that first. The problem is you're going to have to pay your friend back. Make sure you pay them back. But if you do that, then when you're really in a pinch, you can always borrow from friends or family. These payday loan people, here's what they'll do. They'll do something with you like, Okay, you need $200 today. We're going to loan you $200 today because we know your rent is late or your car payment is late. You need $200, but at the end of the month, you're going to have to pay us back $250. So you take their $200, it gets you through a pinch, and then on payday at the end of the month or the first of the next month, they're going to take out $250. Now, that means you actually paid $50 in interest. Now, that may not seem that bad to you. You paid $50 in interest, but you only borrowed $200. $50 is a fourth of 200, which means that's actually 25% interest. But here's the kicker. Did I spell that right? Interest? That doesn't look right. Interest, yeah. Here is the kicker on that. That is not the annual percentage rate. You just paid 25% for that loan in 1 month. If I want the annual percentage rate you just paid, you paid 25%. Since that was your monthly rate and there's 12 months in a year, your yearly rate would be 25 times 12. You just paid a 300% annual percentage yield for that loan. And that's what they're supposed to show you. They're supposed to show you that, hey, we're charging you a whole lot of interest. Try to stay away from them. And by the way, when I Googled it and started looking at the interest rates, I saw interest rates between 260% and 1,860%. It was insane, and people are paying that. So try not to do that. It gets you in a really bad cycle. All right, so let's look at the a problem, just to show you how you would work the problem. I love this problem. Actually, whenever I was teaching this class, I was teaching a math, sorry, I'm trying to make it bigger for you. When I was teaching finite math for the first time, I was 30 years old, and I'm 49 now. Gosh, time is fun. When I was teaching finite math for the first time, though, at 30 years old, I did this problem with a class, and it changed my life. It absolutely changed my life. I'll tell you how after we get it done. Jane deposits $2,000 annually into a Roth, we're going to talk about that word in a minute, IRA. An IRA is an individual retirement account. A Roth is a specific one, a specific type, kind of like a 401k, but different. We'll talk about it in a little bit. At 6.85% compounded annually for 10 years. She then leaves it alone for 25 years, drawing interest until she retires. How much money will she have in the account at her retirement? Now, Jane is making annual deposits into an account. This is an annuity, which means I will need to use my annuity formula. So I will plug in, and I'm going to set this formula right here, just so I can see it and you can see it. And I'm going to plug in every amount that I need into this formula. The amount she will have in the account is her payment. What was her payment? She's putting in $2,000 a year times, and that's just a parenthesis, but then there's going to be another set of parentheses to go with it. 1 plus her rate, 0.0685. Remember to change a percent to a decimal. Dr. Pepper, percent to a decimal, 2 places to the left. So I moved that 2 places to the left. She's doing this yearly, which means in my formula, I'm looking at my formula, N is 1 to the number of times compounded per year times the number of years. She does this for 10 years. Now notice I put the parentheses around that. It's very important. I need those parentheses. Minus 1. Notice my minus 1. End parentheses. Ooh, you can't see. Okay, there we go. Now that will all be divided by, I'm still looking at this annuity formula, rate 0.0685 divided by N. I need parentheses. Now, I will enter this in on my calculator, and let me tell you, students have the hardest time entering this in, and here's what I tell you. You have to get to know your calculator. You have to know how to do an exponent on your calculator. I sent you an email with how to do it on a graphing calculator, I believe. But you can Google it, look it up, Google your calculator to find out how to do this. But here's how you enter it in on your calculator. Read it out loud. So here's what you're going to enter. 2,000, open parenthesis, 1 plus 0.0685 divided by 1, end parenthesis, to the, so if you have to hit x to the y or y to the x, you do that. If you hit the little caret, do that. If whatever you do to get into the exponent, parenthesis, 1 times 10, end parenthesis, minus 1, end parenthesis, divided by, open parenthesis, 0.0685 divided by 1, end parentheses, and hit equals. So if you read it out loud, it will guide you. If you get a syntax error on your calculator, generally that means you forgot to do 2 parentheses in a row, or you forgot to close a parenthesis somewhere. So it's usually a parenthesis issue. Now, I've done that, and I got $27,437.89. Now that was me rounding to the nearest penny. If you are told to round to the nearest dollar, I would look at that 8 and say, let's bump it up. It's going to be $27,438. If I am told to round to the nearest, that's cent, round to the nearest dollar. If you're told to round up to the nearest dollar, it would still be an 8. Remember though, the round up, when they say round up to the nearest dollar, that means like if I had $8.05 and you go into a pet store and they say, would you like to round your total up to the next dollar to help the animal shelter? That means no matter what this change is, from a penny to 99 cents, if you round up to the nearest dollar, that would be $9. If I just tell you to round to the nearest dollar, that would be $8. So beware, look at your instructions when you do this. And of course, if I round to the nearest cent, you have to look at this place on your calculator. If it's 5 or more, you take that number up 1. But I had already rounded to the nearest cent on that. Okay, so how much will she have in the account at her retirement? Now notice this was only for 10 years because Jane only had money to put in this for 10 years. Then she leaves it alone. Now when she leaves it alone, she's no longer making payments in the account, which means it becomes a compound interest problem, not an annuity anymore. So it was an annuity for the first 10 years, but now I'm looking at my compound interest formula here. I want to know how much she's going to have in the account. So I'm looking at this formula. A equals principal times 1 plus my rate divided by N to the N times T. Now, how much is her principal? Well, it's the amount of money she's putting in that account. Times 1 plus, what's her rate? It's staying in the same account. Whoops, wait a minute. How often are they compounding? They're still only compounding once a year because she left it in that same account. She really should move it or tell them you need to start compounding per month because you want it compounded per month. The more often they compound, it's better for you, but it does peak out. That's that continuous compound interest. But you want it at least monthly. Monthly is really good. But she's not monthly, she's annually. How do I know that? Because I look at this problem and it says compounded annually and she's leaving them in this, She's leaving it in the same account. But it went from an annuity to plain compound interest because she stopped making payments in the account. For an annuity, you have to be making those payments in the account. Let's see, to the N, it's one time per year. For, now she leaves it alone for 25 years. Now, I did that. Let me see. I did that, and Jane ends up with $143,785.10 in her account. In her account. My throat hurts so bad, y'all. Oh, I gotta move this over. Sorry. Okay, so that's how much she ends up with in her account. Now let me make sure, did I answer the question? How much money will she have in the account at her retirement? Jane's going to have $143,785.10 in her account. Now, here's what's great. How much money did Jane initially invest? Y'all, she only put in $2,000 per year, so once per year for 10 years. Jane only put in $20,000. But the fact that she was young when she did it and she just let it stay in the account for an extra 25 years means she had a nice amount at retirement right there. Now I want to go revisit this word Roth for Roth IRA. I want you to remember that word, Roth, and Google it. Actually, I sent you a link on email, or I will send you a link. But a Roth IRA, here's the really cool thing about a Roth IRA. With your 401k, that's also an IRA, individual retirement account, but with your 401k, that's something called a tax deferred account, which means if you put in $2,000 per year, you don't pay tax on that $2,000, not until you draw it out later when you retire. So that helps you some on taxes now, but you are going to pay the taxes on that account when you pull it out. Not only will you pay taxes on the $2,000 you put in, but any money that $2,000 makes, you will also pay taxes on when you take it out. The great thing about a Roth IRA is that Jane put in $20,000. She got no tax break on that $2,000 per year. She paid her regular taxes on it, just like you would on any income that you make in the year. So there was no tax deferred here. So she paid the taxes that year, but then she put it in this Roth IRA. When she pulls this money out, she doesn't have to pay any taxes on the money that her $20,000 earned. So she will never pay taxes on this $143,000. She can pull it all out and it's laid in her hot little hand. And you don't get things like that. That is a wonderful perk that America has, and too many people do not know about it. Go see your bank or see an investment company. It's not going to cost you anything but your initial investment. If they're trying to charge you fees up front, you're at the wrong place. They want you to start that account because when you do, they can use your money. So you can start it, most places you can start it with as little as $50, $100. Start a Roth IRA, and as you make more, you can put more in it. I did, and I'm retiring soon, and I'm 49. So it changed my life seeing this problem. I'm hoping that it changes yours too, especially if you look that up. Look it up and tell your family about it if they don't know about it, because it's a really big perk, but so many people don't know about it. All right, let's look at another example. And I want to show you an amortization. I'm going to kind of just go through this quickly. Before purchasing my new $80,000 home in 1992 at 7.5% interest compounded monthly, I looked at my payments for a 15-year loan versus a 30-year loan. Now, this is one of the perks of being a math person. I actually did the math, and the math was a little harder to do in 1992. I didn't have access to a spreadsheet, not easily. So I actually got the formulas, looked at it. Now, I want to tell you, I used the word new on purpose because I wanted to tell you this. I was 25 years old and I was only looking at used homes because I thought I couldn't afford anything better. Um, but I just drove by and said, I want to look at what these new homes look like. So I drove in and put my name on a list for them, gave my phone number, my mailing address, and at the time I didn't have an email address. Um, and I told them, well, I'm just wanting to look. And the house that I'd picked out that I liked was about $105,000, and I couldn't afford that. I could only afford an $80,000 home. What happened was they called me back a few months later because they built a home just like the one I liked, and it sat there for a while. The longer that house sits there, the more they reduce it. And finally the man called me and said, you know what? This house, we've got to get rid of it. And we are willing to sell it for $79,900. So I just rounded it up for $80,000 for us. And I came in and I bought that house. Now, and I love that house. I still love that house. I don't live in it anymore, but I still own it, and I love that house. Now, what are the monthly payments for a 30-year home loan? What is the total cost of the home? This is paying off a debt. If I were buying a car, a house, I will be using this formula. And to keep me from having to write it, because I'm not wanting to take any more time than I have to, I'm going to put it right here. There's my amortization formula. Now, we have this payment. I want to look at the payments. My payment equals principal, $80,000 house, times rate. My rate was 7.5%, so 0.075. It's monthly. That's how often I'm going to make my payments. So that's how often it's compounded per year. 1 minus, parentheses, 1 plus. By the way, when you see a bracket that's the same as a parenthesis, they're just trying to show you the difference. That this one goes with this one and this one goes with this one. But you just enter the parenthesis key on your calculator. Rate, 0.075 divided by 12 to the negative, and I'm going to put this in parentheses, to the negative 12 times, and I'm looking at the 30-year loan here. Let me extend that. And don't forget to end that parenthesis. Notice it's in the formula. Whoops, let's come over. Don't forget to end that parenthesis. Sorry about this, y'all. I think as I do this more and more, I'm going to get better at it, but I got so much going on. And I'm at home in my little study, and there's stuff everywhere. Okay, so I actually did that on my calculator. How did I do it? I read it out loud and put it in my calculator. Now let me tell you, some students ask me, do I need a parenthesis? Do I need parentheses around the top? And here's my answer to that question. I happen to know that that's going to be that times this divided by the other. Well, it's going to multiply and divide in the order that it occurs, and that's fine. I do not have to have parentheses around the top. It will come out correctly. But if you have to ask me if you need parentheses around the top, then you put them. Because if you put them around the top and bottom, an extra set, and you don't need them, you will still get it right. But if you needed them and you do not put them, you will get it wrong. So that red set of parentheses, I don't actually have to have them, but if you have to ask me, you put them. Okay? Now, when I did that, I got a payment of $559.37. Now that's only your paying the bank for what they're loaning you. That's not going to include your taxes and your insurance, which also go into a house payment usually. But this is my basic house payment, about $560. Now, what is the total cost of the home? Well, if I do a 30-year loan, I'm going to look here. Let's see, do I have room? I'm going to do my total cost. My total cost will be that $559.37 times 12 times per year times for 30 years. And that's a total of $201,300 $373.20. That's the total cost of the house. So my $80,000 home, if I do a 30-year loan, is going to cost me over $200,000. Now, second part says, what are the monthly payments for a 15-year loan? What is the total cost? Now I'm going to cheat a little so I don't have to write this whole thing over. And what you want to do here, I'm going to come where it says the 30-year loan, I'm going to use the same formula, but where it says 30, I'm going to put a 15. So that formula, it's the formula, the only thing that changed was it's a 15-year loan. So that formula is here, and I'm going to re-enter this whole thing in my calculator. If you know how to edit, if you're using a graphing calculator, you don't have to enter the whole thing. But if you don't know how to edit, I'm going to enter the whole thing, but instead of that 30, I'm going to put a 15 for a 15-year loan. When you do that, you're going to get $741.61. Now, I hope you're pausing this and actually entering it in on your calculator, because you need to make sure you can enter it in and match these answers. Now, I also want to know the total cost of the home. The total cost of the home will be $741.61, 12 times per year for 15 years. Notice it was 30 years before, but now it's only for 15 years because I'm looking at the 15-year loan. And when I do that, I get $133,489.80. Now look at that. My gosh. How much more a month does the 15-year payment cost? Well, I'm going to do my $741.61 minus the $559.37, and that means it's $182.24 more per month. Now that's kind of a lot, but it's less than $50 extra a week, and you have to think about it. You just have to think, can I swing an extra $40-something a week or not? But if you can, look at this. How much does making the 15-year loan save on the cost of the home? Well, instead of the total cost being $201,373.20, it will be $133,489.80. And that's a total savings of $67,883.40. Y'all, I went with the 15-year loan, and I do this in class with my students, so I'm going to read it to you. After doing this, I got the 15-year loan. I bought that house on my 25th birthday and had it paid off before I turned 40. Because actually, when I would get a little bit of extra money, I'd put like an extra couple of $100s towards the principal. And I did that at the beginning of my loan, so it saved me thousands of dollars. You want to do that too if you can. It's now worth over $165,000, and I own it. I lease it out. It pays to no math. Y'all, I never knew anybody who bought a house and paid it off. I certainly didn't know anybody who leased a house out. And the house, it's not making much money. It actually doesn't make me much money, but it's a good investment. I'm just holding on to it because, like I said, I've got that Roth IRA. I've invested in some IRAs because of doing this math. Honestly, teaching this math in my finite math course is why I'm going to be able to retire at 50 years old. It's pretty cool, and I wish that for you as well. Now, make sure that you can put this in on your calculator. Although you do not have to memorize the formulas, you are going to need to know when to use each formula, and that's what everybody just wants to go, when to use it, when do I use what formula? Well, simple interest, compound interest, when you're just putting an amount in and you're just going to let it ride, it's going to sit there for years, it's going to sit there, you're going to use this. The annuity is when you are investing and you're going to put a payment in. Remember, the pay is your payment on an annuity. How much am I paying in every month, every year, every week, whatever? That's the amount in the account. Or if you know you're going to need $200,000 when you retire, how much do you need to put in every month? You would use this formula. They're really the same formula. One solved for P, one solved for A. If you're doing compound interest, don't forget PERT. If you are paying off a debt, that's your amortization loan, and that's when you're buying a house, buying a car, credit card. You know you're going to be using this one. And remember, this is the effective annual yield. So whenever you are comparing interest rates, which interest rate is better, you're going to look at the simple interest rate that would yield the same amount. Compare them that way, that annual simple interest, so that you can decide which one you want. You want for an investment the one that yields the highest simple interest. Okay, I think that's everything I wanted to tell you about math of finance. The videos that go along with your textbook are pretty good, and they're very thorough, and they look a lot nicer than this. So I hope you'll watch those videos, and I wish you the best of luck on your exam. Make sure you go back over your questions. Make sure you round the correct way that they tell you to round, because if you're not following directions, you're wrong. You have got to follow directions. That's a very important part of working any problem. So make sure you go back through, read the directions. Did you round to what they said to round to? Did you enter in or circle the answer that you meant to put? So don't make a simple little mistake. Never miss questions you know how to do. That's my thing. If you absolutely don't know how to do something, miss it. But I can't stand it whenever people know it, they understand it, and they just make blatant mistakes. It's just simple mistakes, but mistakes are mistakes. And the right answer is important. If your bank tells you you have $200 and you have $2,000, that one little decimal place they accidentally messed up on is going to make you pretty angry, and they better get it fixed fast. And someone can lose their job over one little decimal place. It's important. Okay, good luck, and I'll see you in the next video. Bye-bye.